So I was at Google before 99 to '05, and uh, after the IPO, I stayed for about a year, and afterwards, I just decided I really wanted to do my own thing and see how it turns out. So my brother and I, we started this company called ImageShack, and we ran it for 6, 7, 8 years or so. Um, by kind of like 2 years ago, we realized it's really not going to be like $1 billion company. So I essentially decided to close it down, and I ended up doing something else.
Are you talking about
Uh,
ImageShack right now?
ImageShack, yeah.
I,
So
is it?
so I
Did
I
you
found
sell it or close it down?
I closed it down. The site is still up, and it's kind of like winding down. So we pretty much like got rid of all the free users. So it's became more of a premium service. So it used to have like at its peak 60 million uniques coming every month, which is a pretty good number. But
Yeah.
unfortunately, the infrastructure costs just caught up with us, and we couldn't really make as much money as we wanted. So investors and I, we decided to essentially to move on and do something else. So now I'm doing something else. So between that and that, I was involved in a number of investments. So right now, if you go to my angel.co profile, you'll be able to see like all the companies that I invested into. So Peer 5 is one of them. I really like those guys. Those guys are from Israel, and they're doing something really cool with video sharing essentially. So they're kind of like a torrent for the web or for the web browser. So like if everybody's watching some sort of a broadcast in this one region, the browsers actually can talk to each other and create this kind of like a peer-to-peer network to save on bandwidth for the original broadcaster. So that's pretty cool. It's kind of like, I would say it's peer-to-peer CDN, like an elastic CDN that doesn't have any infrastructure. So, and that's pretty cool.
So there's actually no infrastructure at all. I'm sorry, no infrastructure at all. It's just peer to peer. I
Yeah.
When I first saw the video, I thought there was the infrastructure, and then on top of that, there was peer to peer. But you're saying it's just peer to peer.
So as far as I know, they have the kind of like the syncing layer, the metadata, kind of like would be a torrent tracker or of some sorts. And in terms of data exchange, it's actually happening browser to browser to browser.
Hmm.
So, and that's what makes it very interesting. So let's see what else. I also invested in a company called Wakey. That company is pretty cool. They have this app where you can. It's kind of like interesting. They call it a social alarm clock. So let's say that you're like have some time and you want to call some girl and wake her up. You can do that. So you open up this app and you say, I want to call and wake some girl up and talk to her about something. And you get a list of the requests, like saying, wake me up at 6 p.m. And she might be in a different country. So you push a button and the app calls using voice over IP, and it will wake up the person for you. And then you get to talk to them, whoever they might be. So it's like totally safe because it's totally anonymous, and it's very entertaining.
So how do you
So
protect yourself from being called by whoever? Do you have to be on the app and say, yeah, I'm okay with being called?
yeah, basically, like
Okay.
for example, let's say that I want to be woken up. So what I do is I set the alarm at like 6 a.m. and then I set the parameters as far as who should call me and what should they talk about when I wake up. So
That's interesting.
that's from the other side, and that gets broadcast to their social network, right? And somebody will call me at 6 a.m., wake me up, and sing me a song or something like that.
That's really interesting. Do you think we're moving towards a time when we have just one company trying to control the one chat? Let me try to elaborate on that because that just kind of came out of nowhere. But for example, with the Facebook Messenger, they're starting to add video, they're starting to add calls, free calls, and chat at the same time. So instead of having a text or a messenger for texting, and then a separate mobile caller, and then a separate video caller like Skype or Google Plus, do you think they're trying to move it so that we have one program that does it all?
Well, I think this is certainly what they want to do, obviously. I mean, Google clearly wants everybody to use all of their products so that there's higher likelihood of them using their search. Facebook wants people to stay on Facebook, so they come up with all kinds of products for communication to, to make people, to have people be entertained using their products. I mean, my feeling on that is that as companies compete, consumers win. So ultimately, if very large company is trying to make better products, by all means, let them compete, because at the end, we're the users who are going to be benefiting from it. So again, like we're making this call, video over IP. It's totally free. Nobody's like, jamming the transmission because we didn't pay. That's great, right? So there's a lot of investment have been done in this sort of thing.
Interesting. Well, so usually what I like to do is get started with an introduction and then move into the interview. But I kind of like this discussion we just had. I think it'd be pretty interesting to some people. So actually, let's just change it up today. Let's do something, get out of our comfort zone, and let's just dive into the episode and roll on like there was no introduction. So my name is Christoph Limpelaer, and I'm the host of ScholarlyCode.com. And with me today, I have Jack, and correct me if I'm pronouncing your last name wrong, but is it Jack Levin?
Levin.
All right.
Just like Kevin with an L.
Kevin with an L. Easy enough. Well, thanks for joining me, Jack. I really appreciate it. And you do have a really interesting background. I don't know if people get a chance to look you up, go ahead and do that. But at the same time, I want them to hear it from you. So can you tell us a little bit more about your background? I know you said that you started out, or you worked at Google, and I think you worked as a first network engineer. Am I right?
Yeah, that's correct. So I moved into the area in '97, shortly after the graduation from University of Missouri in Columbia. Did 1 year at a company that very quickly closed because they ran out of funding. I met Sergey at Stanford, and I didn't go to Stanford or anything. I didn't take classes, but I was rollerblading there, and I met him at the job fair. And Sergey was there, kind of with his printed cards, printed business cards. They were just starting, and so I asked him, I'm like, so hey, what are you guys are up to? And he said, yeah, we're building the search engine. It's going to be really great because it's like the best. I'm like, well, let me think about it. There's like 7 other search engines, and they're bigger companies than you guys. So how is that you're great? And he didn't really explain much, but he did say it was amazing. So I figured, hey, I'll give it a try at home, which I did. And Google was amazing. There was no broken links, no porn, no ads. It just worked really fast and got me to the data that I really wanted. So the next morning, I just called them up and I said, hey, I'm coming in for an interview. So I came in. I was out of a job right at that moment, and joined right away as an employee number 21. Started in Palo Alto. Essentially, it was kind of funny. So both Larry and Sergey, they interviewed me and they gave me a job. And on the first day, I came in. So I asked Larry, I said, okay, so what's my job? Like, what should I do? It's like, see that pile of stuff in the corner of the office? Take it to the data center and install it. Make sure it works well. I'm like, okay. And then on the way out, he said, hey, oh, by the way, don't forget to install 2,000 servers that are being delivered tomorrow. I'm like, all right, okay. So as long as I have enough cable and power, I'm pretty sure I can plug everything in. So, and as they say, the rest is history. Google quickly became a very large company. It had really good VC firms investing into it, Kleiner, Perkins, and Sequoia. So it was a lot of fun to work there. So, and I really enjoyed it.
Did you have a lot of experience before doing that, or did you just kind of jump in and get started and figure it out as you went?
So I had a lot of IT experience, specifically in kind of like the area of networking, VPNs, things like NFS and large storage, sharing units and stuff like that, and and switching and routing also. So, and when I joined Google, there was not a single person who was really into it. So, and clearly, when you're receiving and installing 2,000 servers, you have to come up with some sort of a plan, right? And there, I was able to kind of like apply, my interest and learn in the process as well. I mean, there was plenty of things that I didn't know. So, and I think I was like 23 or 24 at the time, so it was a wild ride. So for the next 6 years, I was at Google essentially building data centers and building infrastructure. So, and by the time I left Google, it was like 8 or 9 thousand people in there. So it was really a different company from what it was before.
And how long did you stay there?
About 6 years.
6 years, so a good little while.
Yeah.
I want to ask you a little bit more about that, but first I want to thank Linux Academy for sponsoring this episode. If you listened to the previous episode, you already know that they hired me, so I'm working at Linux Academy now as part of, or as an instructor and as a developer. And by the time that you listen to this episode, we've already come out with a bunch of new courses. I'm specifically working on a course on AWS Lambda, so talking about serverless architecture, code execution with events, just a lot of really interesting use cases, like creating thumbnails from images when you upload them to S3 and having that all automatic. There's so much you can do with it. I'm really excited to release this course. So go ahead and sign up today at scaleyourcode.com/Linux Academy to get a 24% discount. This is only $22 a month. And I'd love to have you join and to see you in the community. We do have a community where you can interact with instructors. So go ahead and sign up and say hi, and I'll be sure to check you out and say hi back. So Jack, you said 6 years at Google. Then after that, what happened? Did you found ImageShack right after that?
Yeah, basically that's the story, is that, my brother and I, he actually basically said, hey, I want to do this image hosting thing. Let's see if it works. I'm like, sure, yeah, let's see if it works. So the funniest thing is, and it's an interesting story, we were so spoiled by the early success. Literally, we launched the first server and like immediately made like $100 that month.
From users signing up, like premium accounts?
No, it was completely free. It was all Google AdSense actually.
Oh, wow.
So back then the ad market was like really immature, so people didn't know like what should be the click, cost per click be. So we were literally like getting hundreds of clicks that were bringing us hundreds of dollars initially. So each click would be like 80 cents to $1, which was amazing. So it kind of took off from the day one. Within a few months, we already were running hundreds of servers, and it was just like, bending under load. It was like that popular, and I was wrecking some serious money. So by the time I talked to Sequoia, thinking that I really kind of want to turn it into a real company, 2 years have passed. It was 2007, and so I came to Sequoia and I showed my users, which was like 25 million uniques a month. We were making a few $1 million a year, which is pretty good. It was only two of us.
Nice.
And that was a pretty good sell. I mean, like a pretty easy sell. I presented the PowerPoint, and then I went back to the office. 2 hours later, Sequoia was with the term sheet, so which was amazing. So we got the deal signed, and kind of like the rest is history. So so going back to the fact that we were spoiled, like we're really kind of like I would say that we always thought this would be a technology company. So we didn't really invest in sales or marketing or anything like that. It was very similar to Google in a sense, like how quickly it became the thing that people wanted to use. After a while, though, within next 7 years, as MySpace came up and Facebook came up, it was very clear that people would rather actually store and share their images on social networks rather than some sort of standalone thing, which was ImageShack. And we also had plenty of competitors. I mean, there's Photobucket, there's Imager, there's Flickr, so the market was very fragmented. So in 2012 or 13, it kind of became apparent that ImageShack as a standalone entity is not going to be a $1 billion company. So we decided to shift gears and do something else.
And I remember using ImageShack when I was much younger. I mean, this was years ago. I can't remember exactly when, but I just remember vividly. There was the Photobucket, there was ImageShack, and I remember using them a lot just to share different kinds of images. And like you say, nowadays, most social media networks have their own image platform where you can just plug it in and you're good to go. And that reminds me of Twitter with TwitPic. When Twitter didn't even have a way of sharing these images, TwitPic saw that market. They got really big. And then Twitter was like, well, actually, you know what? We're going to create our own. And that just essentially almost killed it off. Or it did kill it off, I guess.
So for a while, we were YFrog, which was actually a competitor to TwitPic.
Oh, really? I didn't realize that.
Yeah, YFrog.com was a big thing on Twitter as well. Essentially, we were two big players who were doing image hosting for Twitter.
Did you see my interview with Steve Corona?
I didn't,
No.
but I'm going to check it out.
Yeah, he was the CTO of TwitPic for a while, and now he's with Big Commerce. So he's moving on to great things. He's doing a great job, as far as I can tell. But so you actually did see one of my episodes with Kelly Sutton of imgix, and that's when you reached out to me and you said, hey, I want to talk to you about my new company. We're just starting this new product and we're about to announce it. Why did you contact me about this product?
Well, basically, I figured that this is something you might be interested in to talk about. And I personally am very excited about this new company that I have started. So we were around for about 6 months. And I think it's going to be really great and become really the part of the stack of the cloud infrastructure. Mm-hmm. So imgix, actually, I have a few friends working there, and those are like former Google guys, and have a deep respect for what they have done. We're doing something different. Even though the products look similar, we both do image processing, where they have built data centers full of Macs. We decided to go the cloud route. We decided to go to AWS and just use EC2s. So basically, the product that we have is called Imagizer. And Imagizer has been a product running on our own servers for a while, doing all kinds of things. We actually have a set of clients. One of them is DirecTV. Another one is Uyala. Those are pretty big companies. And they have had great success with using the product to do image processing. So the biggest differentiator as far as what we're trying to offer, Imagizer is what we call it. And it's not a service. Not a service at all. It's cloud software that you get to run on your own EC2. So in other words, you log into your own AWS account. That's where your image library likely going to be anyway. You go to the Amazon Marketplace. You get Imagizer to start, and that's it. You don't even pay us. There's no MSAs, nor any sort of sales process. You simply click one button, and it's good to go. And you have your own instance of Imagizer. Essentially, think about it as if it was a Photoshop on the cloud, and it's running for your apps, or your website, or your mobile site, or what have you. So it pretty much does everything that imgix does, and everything that's Cloudinary does, except it does it very fast, much faster. We can resize and transcode and process images in 25 milliseconds or less.
Wow.
And point is that you don't even need to run the CDN on top or do any sort of caching. Once the Imagizer instance receives an image, it can transcode all images into different resolutions pretty much in parallel. And that's the biggest differentiator. So when it comes to other guys, and we actually tested them, so both imgix and Cloudinary, they're pretty slow when it comes to initial transcoding. It's actually about half a second. We can do it in 25 milliseconds or less. So, and it doesn't really matter how large the initial image is, because the way that we have written our algorithms, we're actually using a lot of interesting computer vision stuff to decompress and transcode JPEGs in parallel on the fly. Like, for example, a lot of people don't realize that JPEGs are actually 12-bit images. They're not 24-bit images. They're not RGB images. They're YUV images.
What does that mean?
So YUV is not red, green, and blue. So the pixels are described in a different way. Where RGB is described by 3 bytes per pixel, YUV is actually 1.5 bytes per pixel. Now, the interesting thing about it is that you have the luminosity, the intensity, and the grayscale in YUV. And there's like a great article on Wikipedia that describes it all. It's actually better for compression. That's why it's used in JPEG. So what we're doing is we're actually found a way to do decompression by going natively into the YUV channels and decompressing them in parallel and doing transcoding. Most of the libraries out there are actually would take a JPEG image, up-convert it to 24 bits, which actually would double the data in your memory and waste a lot of CPU time. So we're foregoing this process completely. And we have built the service by essentially setting the EC2 instance so that it is extremely fast. The other thing that we're doing differently is that we're actually using native Intel, I would say, vector math to actually make this sort of computation very, very quick. So in other words, it's not an iterative process. It's a single-threaded computation and transcoding of visual media that is done in parallel by using very unique way of using registers within Intel architecture.
I see.
So that's how it's done. So it's pretty much written from scratch. It's written in C and assembly. There's no ImageMagick anywhere, obviously. Otherwise, it just would not be fast. So the coolest thing about it is that like people ask me, so how much does it cost us if we like convert 1 million images or whatever? So we usually say there is no cost for a unit of conversion. It's just how long are you running your EC2 that's what your cost is going to be. 22 cents an hour is just a few bucks a day, is the smallest EC2 that you would launch with Imagizer. And you can shut it off an hour later, right? There's no contracts, again, it's completely on demand.
Which instance type is required to run this?
Any. So it starts with M3 medium,
okay,
and it goes up from there. So M3 medium would cost you about like 22 cents an hour. And in terms of pricing information or like who do you pay, right? You just pay Amazon. Because we're Amazon partner, they just give us a cut of the software licensing fees.
I see. So you went to Amazon and you looked at their machine types and you optimized this transformation for the kinds of CPU they have, for the kinds of hardware they have, and the kinds of machines they have. And is that why you have to start at a minimum with an M3?
Well, the reason why we're starting with M3 is because anything smaller is like literally half a core. So it's really the smallest unit where you have a full core that you can use and transcode images quickly.
So that makes a huge difference in the amount of time that it takes to do that.
Absolutely. So just to give you a comparison, M3 medium will do about 50 to 75 conversions per second in 25 milliseconds or less per image. Now, if you used ImageMagick, it would be like 5 to 10 conversions per second before you actually run out of CPU capacity. Mm-hmm. Now, if you go to the largest EC2 that Amazon offers, it would cost you, well, a few bucks an hour to run it. But the largest EC2 would do about 2,500 conversions per second. That's a lot of data. Yeah. So it's actually would almost, I would say, not be limited by the CPU, it would be limited by the I/O. So in other words, how quickly can the original images come into the box? How quickly can the network interface can send out all the processed images out? That would be the limitation, not the CPU. That box is just that fast. Mm-hmm. And we actually tested them head to head. We would bring up really large EC2 instances, and one would be testing the other, and we literally would get 50 milliseconds per image converted when the box is fully loaded. Usually it's about 25 and about 2,500 per second. Mm-hmm. So,
did you learn about all this from ImageShack or even Google? Or is this something that you just kind of thought of, hey, we really need this kind of tool? I know a little bit about images. Let me dive deeper and figure out how they're architectured, how the CPU is architectured to process these. And then you kept learning, or did you hire people that were really good at that? How does that work?
So the way it worked is that essentially ImageShack was dying under load. It was getting like 2 million uploads a day, and for every additional image we had to produce like 5 different copies. So we were quickly running out of space. So what I did is I spent doing some research on the side, and I found this Japanese paper And this Japanese paper was actually from some sort of Japanese company. I don't even know what the name is anymore. It was like 3 years ago. But they described the method of how the JPEGs can actually be converted on the fly into pretty much any format. And gaining some insights from that paper, actually translating it, and then doing some early prototypes, I was able to create a command line utility that actually runs pretty well. Then we kind of realized, hey, command line utility is great if you want to do batch operations, but we really want to do it in real time. So besides really fast algorithms, optimization of the server level, which would help concurrency. So yes, of course, I'm coming from an image background because I dealt with billions of images in the past. The product, which is Imagizer, essentially came up from the fact that a lot of people basically approached us and said, hey, you guys know images. What can you do for us in terms of giving us an ability to scale images and optimize them to any format that we want? How can we do it? How can we partner with you guys? And back then, that was like, 1 or 2 years ago, we weren't really at AWS yet. And the solutions that we were providing would be like, okay, well, we can give you some sort of a box, which is like a physical piece of hardware, maybe some service. And I realized how incredibly unscalable this business is, because it takes like 3 to 6 months to actually sign the customer up. Eventually, they may agree to run it or not. I mean, it's just a waste of time. So I decided to do something better. Just modify the engine that we created for Amazon EC2 so that anybody can run it on demand. And that actually makes my company completely without infrastructure. We're just develop software. So we're using Amazon. We could be actually in Google Compute as well, or Microsoft Azure. It would work, or even software. It will work the same way. So we're using those cloud providers as operating systems. We're using their infrastructure, and we're passing on this sort of dynamic flexibility to our customers. So in other words, we have the engine. The engine is there at the marketplace. Anybody can spin it up at any point, use it for how long they want. There's no contracts of any kind. And we're really hoping that this becomes like the part of the cloud stack. So you have your S3 or an equivalent where your image library is. Then you have this processing layer where the images get chopped up, processed, manipulated, optimized for different clients. Then you have your CDNs, which could be Akamai, Edgecast, what have you. There's level 3 as well. Just put anything, or CloudFront, put it on top, and push your images out to your clients in a really fast manner.
Linux Academy has just added brand new content with 3 new live labs where you get to log into real environments and complete tasks. In fact, I just created my first lab, which walks through creating EBS snapshots with AWS Lambda. You can set a schedule of every day or every week at a specific time, and Lambda will automatically create the snapshots and then delete old ones. Another new lab is on creating complex routing policies, and the third one is on configuring virtual private cloud S3 endpoints and NAT gateways. Sign up with a discount now at scaleyourcode.com/Linux Academy. And by the way, if you're not sure you'll like Linux Academy's teaching style, check out a new podcast called Cloud Cadet, where instructors share examples of their course content. I'm actually a co-host there, and I have an episode where I teach how to send notifications to Slack channels when users sign up. And we do all that with Lambda. It's really fun, and it's one of those lessons in my Lambda Deep Dive course, which is out now. Check this all out at scaleyourcode.com/Linux Academy, and drop me a note in the community when you sign up. I want to personally welcome you. See you soon. Say for example that I want to process an image, and I have I'm using your image, or your machine image, I should say, or it'll get too confusing. But it processes it on the fly really quickly, and then does it save it in a bucket that you specify, or does it always process it on the fly?
So not that and not that.
Okay, interesting.
But either can be used. So generally, here's how it works. Whenever there is a query to Imagizer, Imagizer will then inspect its cache. Is the processed image in cache? If not, then it will then look at a different layer of cache that will say, is the original image in cache? If the original image is not in cache, it will pull that image, put it in cache, and then apply transformation that you requested. The follow-up request will actually hit cache of Imagizer and retrieve the image. Of course, cache will always be faster than transcoding. Transcoding actually uses CPU cycles, where caching is mostly I/O from memory or SSDs. So, but still, we're still able to achieve 20 to 25 milliseconds per conversion. So you don't need to store that image anywhere. You can just show it on a browser. So you have your browser load up all of those images. They all show up in real time. Why do you need to store them? You can always just query more images later. So that's one thing. Generally, there's CDN sitting on top, so it will actually retrieve the processed images, load it up into its own cache system, push it around the world so that people can actually query those cache boxes.
So you're talking about the machine cache, the same machine that went ahead and transcoded the image. It's going to hold it into memory or on disk, and that's what you're calling the cache, right?
Yeah, but there's also a CDN that you can
Sure.
yourself put on top, like CloudFront, for example. Like we have a customer right now. It's called they're called Tonton Malaysia. It's actually kind of like a soap opera Malaysian channel, and it's very similar to Netflix. So we're partnering with a company, Max CDN, and we are essentially kind of like managing the CDN for them as well. What's interesting is that Tonton has everything when it comes to original images at S3, and it lives somewhere on the West Coast, on the East Coast actually. However, looking at their CDN, you can see that the CDN box is in Hong Kong, and 95% of all traffic is in Malaysia, hitting Hong Kong box. So even though our EC2 units are sitting, or they have launched them in Virginia, the CDN retrieves all of the processed images, loads them up into cache, and passes them on to their Malaysian populace. So that works really well. But ultimately, when people ask, hey, are you guys also providing CDN solution? No, we're not. We're really not in that layer of the stack. Essentially, imagine a cheeseburger, right? So it's kind of like a stack, right? So at the bottom is your image library. That's like where the bun is. Then you have the meat, right? Your images are being passed through in there. There's the secret sauce, which is our Imagizer, and then the top of the bun, that bun is actually the CDN. So the whole thing makes it very, very tasty. Now let's say that you remove the Imagizer from it, remove the meat, remove the sauce. You just have, bread, not very tasty and costs a lot of money. So when you run Imagizer, there's few things you're achieving. First, you're getting rid of all of the redundant images that you don't need because you can process them on the fly. So your space requirements go down. You save money there. Two, because images are now compressed and optimized for the screen sizes of your clients, you're no longer wasting a lot of bandwidth. It's really just that simple. Usually we can achieve 60 to 70% of compression for any image out there. Of course, it depends on the app.
Right. How do you tell Imagizer what image you need?
Just by basically, Imagizer is a proxy. So let's say that you have S3 Amazon AWS.com /file.jpg. That's like a file at S3. Now let's say that you want that file to be 200 by 200 pixels. So what you do is you go to Amazon AWS, you spin up your Imagizer box, and it comes up actually pointing to S3AWS.com right there. So the only thing you need to do is you say imagizer.com or mybox.imagizer.com /200 by 200 /file.jpg. As soon as you run that file becomes that thumbnail, and it essentially gets transcoded on the fly.
So you're just storing the largest resolution that you want, and then for example, you have a mobile device that comes in, or you have a retina display that comes in. You can tell Imagizer, hey, this is the device that came in, so we need this image or this format of the image or higher resolution image, and Imagizer spits it out and gives it back to the client.
Absolutely. So the coolest thing here is that you can do responsive design web pages and mobile sites by simply looking at the screen size, capturing that sort of resolution, passing it onto the URL structure, and Imagizer just will output the files precisely of the format and screen density that you want. It's pretty simple stuff. What's not simple is how do you do it in real time without delay,
Right.
without
Yeah.
incurring any sort of latency, and we can do it on EC2. So
And yeah. Okay, I see. And then, what about the strategy of? I know you don't. The way you're doing it now, you don't have any infrastructure, so you're just kind of a software company, like you said. Is it going to make sense at one point to actually have a central location that customers can just plug into instead of spinning up their own EC2 machines? Is that something you're planning on doing, or are you more interested in just remaining a software company and not having the headache of scaling the infrastructure?
we want to be an image processing engine the same way that S3 is your storage cloud, right? There's absolutely no need for us to bring up any sort of add-on on top. We actually don't want any data go through our infrastructure. When you use Imagizer today, you're completely self-sufficient. So in other words, you're not really worried that some engineer might press the wrong button and all of your images go down, right? Stuff like that happens. And that happens when you actually sign a contract with somebody and you're basically putting your eggs in kind of like their basket. And usually like Cloudera or ImageX, they would say, we're better than Amazon. We're better than Amazon because we're providing all those vertical services on top of it. But the thing is that you have to trust them to do the right thing every time, right? So what we're saying is that we're not actually locking you into our infrastructure. Just use your own cloud and use it for as long as you want and run as many instances as you want. So a very large company can quickly spin up 100 instances and do like 1 million queries per second. They can do that. And we don't even have to worry about running a data center at all. So, and let's say they run it for an hour, they finish their whatever they were doing, they turn it off, they just spend like say $1,000. No big deal.
You're right. There's some people.
Yeah.
But what was I going to say? I had a question and then I lost it. Oh, you were mentioning using the Google Cloud Compute engine or using Azure or Cloud or DigitalOcean or something like that.
Or SoftLayer.
Right. Is that something you plan on adding on in the future? Or is that something else that people can... Yeah?
Yeah, so we want to be in every cloud. So in other words, we're treating cloud providers as operating systems, essentially. Like a cloud operating system where you can bring up your on-demand resources to life. We just want to give people the ability to have a choice. Run Imagizer anywhere, wherever they want. Even though if your images are stored at Google, you can still use Imagizer at Amazon because the data input into Amazon is free. You would, of course, pay for the data output, but by then your images already would be of appropriate size and probably would be passed on to the CDN anyway, which you would do with Google anyway. It's the same way, except your images are optimized. So yeah, but you know, some people actually, or some companies, they have startup credits. Like for example, I have a friend who has like $100,000 at Google Compute, and it's a lot of money. They have, you know, moderately sized app. It will take them about a year to use all those funds. So they could totally benefit from having Imagizer running on Google Compute.
Sure. Yeah.
So
going back to the performance of Imagizer, how do you measure this kind of performance? Like when it starts processing and when it finishes processing, what kinds of tools can you use to measure that?
So there's several tools that you can use. There's like basically we use 3 tools that we really like. So we like this tool called Siege, and Siege is just an open source utility that can concurrently query another server. So usually the way we would be testing is that we would bring up this one instance, really powerful one, but like 32 cores. We'll bring up a tester box in the same zone at AWS, and then we would just load up a list of all of the URLs that we want to test on that Imagizer, and we would attack this Imagizer instance with the Siege box. So they're kind of a virtual boxes sitting next to each other, and we would just slam and measure what is that going on the Imagizer level.
Okay.
The other utility you can use is it's pretty good. It's called the HTTP perf, or like HTTP performance. There you can basically feed it your access log. And that's really useful when you're qualifying potential clients, and you want to make sure that usually we would ask, okay, let's see if we can actually improve the delivery times for your apps. How would we do it? Give us your access logs, like a million entries. We would just play back this access log on Imagizer and present measurements in the form of a graph or what have you, or milliseconds per unit, how much bandwidth you're saved, this sort of thing. And the other one is called AB, just Apache benchmark, pretty standard one. You can do plenty of things with that as well.
Yeah, I've used both AB and Siege in the past, and they're both really useful in their own way.
Yeah.
When if you have somebody that's interested in learning more about images, kind of like the way that you have, where you really get to know how images work, how the CPU interacts with the image, how would you recommend that they get started in that process?
I would recommend really looking at OpenCV guides, because OpenCV is a really well designed library. There's a lot of interesting information and white papers there that really can introduce you into vector math and linear algebra, those sort of things. You can really understand what is that's going on the pixel level. So once you really understand how OpenCV works and actually have written some tools, you can jump into essentially pixel by pixel processing. So that's just straight C. I mean, you will already know that, okay, here's an OpenCV function that does matrix multiplication. How can I do it better just using straight C or maybe even assembly? But my initial recommendation would be definitely go to OpenCV, start playing with it, do things like face detection, histogram analysis, and just play with the color spectrums and things like that.
It seems like there's a lot of really fun and interesting use cases for that kind of operation with images. You can do all kinds of, image recognition for one is super interesting to me, for video or for images. There's all kinds of things you can do with that. So I was trying to see if I had any more questions as far as the product goes and building the product itself. Do you think I missed anything, or otherwise I've got more questions about your role at Ambrella, which is the company that has Imagizer, right?
Yeah.
Okay, so the company is Ambrella, and then you have the product Imagizer.
Yeah, so it's an umbrella spelled with an A instead of a U. The funniest thing is that we came up with a name because we really kind of didn't know which product we're going to launch, but we wanted to try different things, so we figured umbrella, right? But then I watched Steve Jobs, the movie, where him and Wozniak are driving in a car and they're like discussing what should the company name be, and he says something like it should have an A in the beginning so that they can be in the top index on any conference. And I figured that's perfect. I mean, I kind of wanted it to be umbrella anyway. I'll just change one letter and
That's all you needed to hear at that point. You thought, that's perfect. I gotta do it.
yeah.
Speaking of conferences, you were at CES announcing the product, right?
I was, yeah. The whole team was there.
I had somebody looking for you, but somehow they didn't see you on the list. I wonder why. I saw the press release, and I'm like, I know they're there. I don't know where they are, but I know they're there. So maybe next time.
It was a zoo, right?
Yeah,
So
it's
hard to
huge.
find anybody in there.
Yeah, how was it? Did you like it? Did you learn anything interesting? Did you see any crazy things?
We saw a quadcopter that you can fly in. So you can
Really?
actually get into it, and you can just use your phone to enter the destination, and it will take you there.
Well, and that goes back to recognition, right? And all this autopilot for the vehicles, and how do you recognize the surroundings? How can you tell if it's a person or not? How can you tell if it's an
Yeah,
object, if it's the road? I feel like that's huge, right?
yeah, it's really big thing in computer vision. I mean, I actually have seen flying wings that can dodge trees. So like a wing would fly really quickly across the field, approach a tree, and then just like swerve around it. So real-time object detection and avoidance is like a really big thing in military applications. And it's also very entertaining as well.
Yeah.
So yeah, there's also things like how would you have like a quadcopter to hang in one place? So they're using this thing called optical flow. Optical flow is essentially a camera that's looking down, and it's actually like if you look at the mouse, it's using something similar, optical flow. That's how it's tracking the mouse pointer. So it's using the reflection of the table. So here there's on a quadcopter there's a camera pointing down, looking and mapping and recognizing whether it's moving at all in respect to the ground. So it's giving its kind of like little controller inputs as far as like it really needs to stay in one place and hover. So optical flow system is one of the computer vision things that is really interesting as well, that quadcopters are using today.
Is that something that you're setting up Ambrella to be ready for these kinds of recognitions? And since you're getting really intimate with image processing and recognition and that sort of thing, is that something that you could see in your future potentially?
Yeah. So I mean, I'm mostly interested in making people's apps faster and their websites faster. I feel like there's really a need for that now. Everybody wants to build an app, even if they're not an app builder. They just want that presence to be there. So we feel like we are taking advantage of the cloud infrastructure. Unlike, so it's a very non-traditional approach where we're pretty much a very kind of puristic company that's building software specifically for the cloud. So we don't have like some sort of modified thing that runs somewhere else and then also runs on the cloud. We're actually changed gears and we're building it directly for the cloud. And that's what makes it very exciting because you get all of the benefits of the cloud infrastructure.
Where did you get this kind of interest in performance like this? Does it go back to Google and working there and having that culture there, or is it just something that as you've progressed along, you're like, you know what, we really need more speed. I like going to websites that are fast or apps that are fast. How did that work?
Yeah, I guess it's both of those things really. So when I joined Google, I worked very closely with Larry Page, and Larry Page was adamant about being absolutely providing beautiful, fast user experience for the search engine. And that's actually what brought a lot of customers to Google initially. So he was big on quality, and he actually kind of like infected me with his enthusiasm. So from kind of like the early days of my professional life, I was always looking for things to run faster. And that's kind of it. I mean, I wanted to develop something like image processing at insanely fast speeds, just to see if it was like achievable. So it was kind of like a personal challenge, right? And at the same time, I realized there's a lot of applications out there to do that. Like you can look at the stats. Like for example, if your site is delayed by 1 second, you're actually going to be losing about 7% in your conversions. Now that's huge. So if you're making like $100,000 a day for some large company, that's like $2 or $3 million of loss yearly. Just if your site is slower by 1 second. So we figured, how can we actually contribute to people's success? And we figured Imagizer is the thing that we can actually give to people to use, on demand, so that people can focus on the product's key features, rather than like really understanding how to resize their images, building all those pipelines, worrying about storage and hard drives and so on and so forth. A good analogy is like, let's say you're building a car that flies. Why should you design a factory to build wheels, right? You can just go to Michelin and buy the best wheels out. I mean, you're really focused on this ion drive that's going to be powering your car that's going to fly, right? So that's like the message to the people out there, is that everyone wants to build something interesting and new and different, right? We don't want to build a clone of Instagram that's like insanely fast, or a clone of Facebook, right? Or a clone of Snapchat. We want to be building something amazing that people would be using. So we feel like we can bring those people closer to their goals. So that is kind of like what's really exciting to me.
If you could give advice to anyone that's maybe just getting started in their careers, or has even been established in their careers, but they kind of want to take it to the next level, what would you say to them?
That's a very interesting question. I would say work your ass off. Because I meet a lot of people, a lot of smart people, and my message to them is like, look, you want to be successful? Do you want to understand like how the technology world works? It actually takes a lot of effort. It takes a lot of self-motivation that you want to apply to yourself to learn things that you otherwise do not know. So I would say, don't be discouraged by difficult things. Work your ass off, and you're just gonna be better every month. So
The reason I asked that is because when you were talking about joining Google, first of all, and then later on creating ImageShack, it just kind of seemed like it was a project that you saw that was pretty interesting to you. And you were like, you know what? Yeah, I'll try it. I'll give it a shot. Maybe I'm misreading this, and maybe it was different when it was the actual situation. But that's kind of the feeling I got from when you were telling me about it. Do you think that's accurate to say that's the case? That
so
you
you're
just
talking about Google or ImageShack specifically?
both, or everything you've ever done, really? Was it just kind of like, this is an interesting project, I really want to pursue it and see what I can do and see if I can beat myself to it? Or
Yeah.
was it just more of, hey, I saw the vision, I knew that Google had something good going on, I knew that ImageShack could have something good going on, and that interested you? How was that?
I think it was the first thing you said. It was basically a challenge. I had no idea Google would be successful. In fact, I figured when I joined, I would give it 6 months and see how it goes. Because there were plenty of job opportunities out there. I figured, hey, they only have like 15, 20 people. They really need help. I can really get busy and help them out and maybe learn something new. I didn't know that Google would become Google at all. It was just a room full of Stanford students. I mean, that's what it was. So to me, it was kind of like a personal challenge. You know, can I help the company become something amazing? And it did, but I totally didn't realize at the time that it would. When it came to ImageShack, it was kind of like shifting gears, I would say. So at Google, I had all the help I needed. So I had project managers and all kinds of people out there, 8,000 people. So there wasn't much of a challenge to me anymore. It was kind of like a challenge, like how do you make an impact in a company that large? And I felt less and less impactful compared to 20 people, right? Like when you're like one of the 20. So when the ImageShack opportunity came along, I'm like, yeah, you know, this is going to be an interesting project. It definitely has some scaling challenges. So I'm just going to jump in and work my ass off and get this thing off the ground, see what it will become. So that was the kind of like the thing.
Well, and obviously worked really well for you, so I'm glad. And Jack, I really appreciate your time. Thank you so much for coming on the show today, and thanks for reaching out. I really enjoyed seeing that you enjoyed that interview, and you were like, hey, you know what? We've got something else that I think you'd be really interested in because we can do it in 25 milliseconds, and that's what got me. I'm like, well, that is extremely fast. How the heck do they do it? So
Yeah.
thank you so much for sharing with us. And if people want to reach out to you or check out your products and under Ambrella or even just Imagizer, how do you recommend they do that?
Ambrella.com, just like umbrella misspelled with an A.com. My personal email is jack@umbrella.com. You can also find me on LinkedIn. If you have any sort of interesting projects out there that you want my feedback on, I would provide that feedback. If you want to connect to an investor community, by all means, reach out to me. I'll try to hook you guys up.
That's right. We didn't really talk a whole lot about your investments, but you are an angel investor and you've invested in a few different companies. If you Google Jack Levin, then you can find all that information pretty easily, so it's not hard to do. But are you on Twitter at all?
I am on Twitter, Ambrella I, so Umbrella Incorporated. That's my Twitter handle. That's what I'm tweeting as right now.
Awesome. Thanks so much, Jack. Thank you all for tuning in. Go ahead and leave a comment to thank us for his time, or to thank him for his time. And thanks a lot for tuning in. Y'all have a great day and great week.
Thank you for having me.
Yep. Thank you, Jack. Bye-bye.
Thanks. Bye.